Hello everybody and welcome back to the channel. In this video we're going to try to cover the Pandas library in as much detail as possible. Now before we continue, I do have one quick disclaimer. Pandas is a library that is built on top of another library called NumPy. So if you're taking this course, I do expect you to know the basics, at least the very basics of NumPy. If you don't, I highly suggest pause the video, read some documentation, or watch another tutorial on NumPy, and it just so happens that I have one on my channel. So I'm going to go ahead and proceed, and if you are still watching, I am going to 100% assume you know at least the basics of NumPy. Alright, so let's go and, well, get started with pandas. So the first question that we often ask ourselves when we're trying to learn something new is, well, what is this thing and what it's used for? Now, if you go ahead and actually search that question, what is pandas, on Google, you'll probably get a definition that this is just some sort of bear that lives in a jungle. But now when you specify the pandas library, then you get this definition right over here. Pandas is a software library written for the Python programming language. So that defines exactly what pandas is. It's a library, specifically a Python library. Now, let's talk about what it is for and what it is used for. So, pandas is going to be used for data manipulation and analysis. So, let's actually look at this portion right over here by going through an example. So let's say that we have a business, a lemonade business, and specifically we're not the ones that are running the lemonade stands. We get children to run the lemonade stands. Yes, we are probably going to go to jail, but nonetheless, this is what we do. So we get a bunch of different children and we have them run lemonade stands over the summer. Now, specifically for the first summer, let's say we got 3 children. We have Ellie, Tom, and Mike. And let's say over the summer they made this much money. So Ellie made $1,402, Tom made $548, and Mike made $1,122. Now what we're going to want to do is store this data and organize this data somewhere so that we can perform some analyses on it. Now, what we decide to do is to go ahead and actually store this data in a NumPy array. So I have a Jupyter notebook up and running. You can go ahead and get yours up and running. Pause the video if you need to. And I'm going to go ahead and import. So I'm going to import NumPy as NumPy. So again, I do expect you to know the basics of this. And of course, you're going to have the NumPy library installed on your machine. So you can either do that with pip, or you can just install Python with Anaconda and then open up Anaconda Navigator, which is going to have a bunch of the different installations already done for us. So this is what we're going to do. So we're going to import NumPy as NP. The first thing that we're going to do is we're going to create a regular Python list. And this is going to be representative of the sales. So I'm going to say sales. The first sale, this one belongs to Ellie, is 1,402, and then the next sale is going to belong to Tom, 548, and lastly 1,122 belongs to Mike. So again, this is going to be our sales, just a regular Python list. Now what we want to do, of course, is convert this to a NumPy array. So over here, let's just call this sales array, and I'm going to say np.array, and I'm going to pass in that list. And now if I say sales array, as you can see here, we have our array. Looking great, looking great. So this seems amazing. We're organizing our data. But now let's say that we need to know Tom's income specifically. And of course, we don't remember. We stored it right over here. Well, the issue now is we're going to have to remember exactly what position Tom is represented as. Is it the first one? Is it the second one? Or is it the third one? Specifically, we're going to have to know exactly what index is Tom's value. Now, of course, we stored it as, well, the first index. But what we're going to need to do is explicitly remember and know that. So what we're going to need to do is something like sales array, and we have to consciously know that, hey, Tom is on index 1. And now, as you can see, we get his value. Now, obviously, this isn't very sustainable. we're not going to remember probably exactly where they are, especially if we start having more and more kids, let's say millions of different records within our array. We're definitely not going to remember that Tom was 4,682. We're not going to remember that he was that index. So we need a way to solve this. So let's think about a way that we can solve this. So currently, this is what we have in our NumPy array. So we have these numeric indices, and then we have our values. So our data has a numeric index. Won't it be nice if instead we can utilize a labeled index? So instead of having numeric indexes, we have, well, labeled indexes. So now if I want to index for somebody like Tom, I can just say something like sales array, and then over here I can say the string Tom, and of course this is going to fail, as you can see here, because, well, there's no index there called Tom, and also an index should only be an integer in a NumPy array. But this would be way, way, way more ideal. And this is actually where Pandas comes into place, because Pandas allows us to create something known as a series. And series are, in effect, NumPy arrays, but they have the ability to add labeled indices. So actually, in reality, a series looks a little something like this. So over here, we have our normal NumPy array with our numeric indices and our value, but we can also add a label indice. So let's actually go ahead and define this. So I'm going to go over here. Let's change this back to 1 just so we can remove that error. And what we're going to do is we are going to create our very first series. Now, of course, to do this, what we're going to need to do is import pandas. So we're going to import pandas as PD. So this is typically how we import pandas as. So as PD, and let me just go ahead and close this off. And we're going to go ahead and import it. Now, if you get some sort of error, that means you probably don't have pandas installed. Go ahead and install it. All right, so now what we want to do is instead of creating an array, we want to create a series. So this is what we're going to do. We're going to say sales series, and I'm going to say pd.series. And then what I'm going to do is I'm going to pass in that NumPy array. So I'm going to say sales array like so. And now what I'm going to do is I'm going to say sales series. Let's go ahead and take a nice look at it. Now, for one, you can see that it's actually kind of organized inside of, or it's kind of organized very similar to a table. So we have our indices right over here, as well as our values. However, this isn't really any different than what we had over here. We're still using numeric indexes. So if we wanted to get Tom's data, we would say sales series, and then we would have to explicitly know that it's 1, and there we go. Now we get Tom's data. So what we want to do is we want to actually add these label indexes to this series. So let's actually go ahead and do that. So the first thing that we're going to do is we're actually going to define all of the label indexes inside of a Python list. So we're going to say Ellie, and then Tom, and then what we're going to say is Mike. All right. And now let's actually go ahead and redefine our sales series. So we're going to say pd.series. We're going to pass in the sales array, but this time as a second parameter, we're going to pass in our label indexes. So let's go ahead and actually do this. And now if we take a look at the sales series, you can see we have Ellie, Tom, and Mike. So in effect, what we ended up getting is this structure right over here. So now if we need to grab Tom's data, well, very, very easy. I can say sales and then series, and then over here I can say Tom. Now notice here that this is a capital T. It absolutely has to be a capital T because that's exactly how we defined it over here. So please keep in mind of the capitalization as well as the spacing, and well, I guess that's pretty much it. This basically has to be exactly what we have over here. If there's any modification, well, it's not going to find the index and it's going to throw an error. So now over here, you can see that we can get, well, 548. But this time we're using a labeled index. Let's actually go ahead and just to prove to you that this is still, in effect, a NumPy array. So we can go over here and still grab Tom even though we just grab Tom by the labeled index, we can also grab Tom by the numeric index. So we get kind of the best of both worlds. How cool is that? And hopefully right away you can see the value of pandas by just simply understanding the series data structure. So far we have created a series by basically passing in a NumPy array as well as a list that contains all of our labeled indexes. But pandas is actually very smart, and it can create a series even if we pass to it a dictionary. So let's go over here, and I'm going to say sales is going to be equal to, and let's say instead of defining it like we did over here, an array, what we can do is we can actually define it as a dictionary. So I can say Ellie, and over here I can say 1,402. I believe that's how much you made, right? Yes. And then over here we can say Tom, and we can say Tom was 548. Awesome. And then over here, lastly, we can say Mike, and Mike was 100 or 1,122. So let's define this dictionary. And actually what we can do here is we can say pd.series, and we can pass in that dictionary. And as you can see, we get the same structure. So it's going to use these keys as the labeled index, and these over here as the data, the values themselves. So I hope that makes sense. And now let's actually move on to another topic of series operations. So now that we have learned exactly how we can create series and exactly what series are and why we would even care about them, we can actually start performing different operations on the series that we have created. So for example, let's go over here to our sales series. So sales series. So now over here we have, just the labeled indexes as well as the values. And let's say we are very cruel people. We take around 70% of the income and we give the kids only 30%. We are most definitely going to go to jail. So what we want to do is maybe we want to determine exactly how much money we make. Maybe we don't care about the total itself. So what we can actually do here is we can do sales series, and then we can actually multiply this by 0.7. In effect, just multiplying it by 70%. And what this is going to do is it is going to multiply 0.7 to every single value that we have in our series. So now if we went over here and did that, you can see that this right here is our income from each particular child. Okay, so this is one thing that we can do. Now, another thing that we can also do is actually combine and do operations between two different series. So let's actually go over here and let's say that we now want to organize our data by the month. So we're going to say April sales, and I'm going to say the sales for April for Ellie, and we're going to make this a dictionary where it's going to be 1,402. We're going to say for Tom, it's going to be, exactly the same, 548. And lastly, for Mike, we're going to say that this is going to be 1,122. Okay, so we have created this dictionary. But now let's say for May, for the May sales, now let's say we still have Ellie, but this time Ellie is slacking. She's making a little less money, so she's making 704. And we still have Tom. Tom also is slacking. He's making a little bit less money. Maybe they're catching on that they're getting ripped off. And let's say Mike completely left. Mike's parents was like, oh, we're going to call the police on you. This is a complete scam. So he's obviously not working for us again. But we managed to get a replacement called Ted. So this is a replacement called Ted. And Ted is now, he's just beginning. He just made $255. So we have these two dictionaries. Let's actually go ahead and convert them into a Panda series. So I'm going to say April, and I'm going to say capital S, just so I can define this as a series. So let's go over here, and I'm going to say pd.series, And I'm going to pass in April sales like so. So now let's actually do the exact same thing for May 1st. Let's just say May sales. So May sales, and we're going to say PD dot series. We'll say May underscore sales. There we go. So now, of course, these are well converted into a pandas series. So what we can actually do here is actually add these two together. So maybe what we want to do is we want to determine how much money that we made or our children made in total for the month of April as well as May. So what we can actually do here is very simply just do April sales and then plus May sales. So we can add these series together. And what actually ends up happening is over here we have the labeled index of Ellie, and it has the value of 1,402. And so what it's going to do is it's going to add it to the value where we have a index of Ellie inside of the May sales series. So what it does in effect is it combines the two indices together, or it combines the common labeled indices together with this operation over here. So Ellie is going to be 1,402 plus 704. Over here it's going to be Tom, which is going to be 548 plus this. And then over here it gets kind of tricky because, well, we don't have a Mike labeled index inside of the May series. And similarly, we don't have a Ted labeled index inside of the April series. So let's actually see what happens here. So once we add it, you can see that we actually get what we expect with Ellie and Tom. However, with Mike and Ted, we get NA. So if it can't find the same label index across the series that we are performing the operation in, what it does is it just gives us NA because it doesn't know what to do with it. But maybe what we want to do is, especially in this case, is, hey, if you can't find Mike in this series, just treat Mike as 0. And over here, just add 1,122 to 0. And similarly, if you can't find Ted in this series, treat Ted's value as 0 and just add 255 to 0. So we can actually do that relatively easily by not really performing an operation like this. But what we can do is we can say April sales, or we can do May sales. It doesn't really matter. So we can say April sales, and then we can use a method called add. So in effect, we're doing the exact same thing, but the way that we're doing it syntactically is different. So we're saying add, and then we're going to say May sales like so. Now, if I just did it like this, and I went ahead and I did a shift enter, you can see that the results are exactly the same. Because again, in effect, this is exactly the same as this. But now that we're using this method, what we can do here is we can pass in another parameter called fill value. And in effect, what this is going to do is, hey, if a certain labeled index exists in one series but not the other, we're going to go ahead and fill the value of that missing labeled index to whatever it is that we want. Specifically, I'm going to say 0. And there we go. So now over here, you can see that Mike as well as Ted are appearing as well their respective totals. So this is some operations. Now, of course, we can do multiple operations. Right here, we just did addition, but we can also do multiplication as well as division, as well as square root, etc., etc. So now that we learned the basics of a series, let us now move on to another data structure that belongs to pandas, and that is DataFrames. So let's quickly discuss what we did a few seconds ago. So what we did was we created two different series, and each series was a representation of the income of each child per month. Now, I know the children were different between May and April, but for this example, let's assume they were exactly the same. So we have April, we have created a series for this. Ellie made this much money, Tom made this much money, and then Mike made this much money. Now, we also created a series for May, and Ellie made this much money for May, Tom made this much, and then Mike made this much. Now, these two series are related. They have the exact same labeled indices. However, they have different, in essence, columns. Right over here, this is representing April sales. This right over here is representing May sales. So what we can actually do is combine these two series together to form something that looks like this. So we're going to have our labeled indexes right over here. And then we also are going to have columns. This is going to be, well, April sales, and this over here is going to be May sales. But at the end of the day, these are all sales for lemonade stands. Now, when we combine two series together, two or more series together to form this kind of table structure, this right over here is known as a data frame. And data frames are extremely popular in Pandas and are used all the time. So let's actually go ahead and start working with data frames. So what I'm going to do is I'm actually going to create a two-dimensional NumPy array that's going to represent our sales. So let's just do an NP. Let me zoom in here. We're going to do NP, and then we're going to say .random, .randint, and we're going to say that this is going to be between, let's say, 200 and then 2000. So 201. So remember, this is inclusive, and then over here, this is exclusive. And then we're going to make this a two-dimensional array, and it is going to have, well, 4 rows and 3 columns. So now if I were to do the sales, I have these random numbers. You should have random numbers as well. It doesn't really matter what they are, just as long as you see them. So now what we want to do is we want to actually convert this into a Pandas data frame. So what we want is we want to have, well, the labeled indexes, so the names of each individual. So this right over here is going to be Ellie or Tom or whatever. And then this over here are going to be the columns. So these are going to be the columns, which is going to be April, May, and June. So let's first go ahead and actually define the names of the individuals, which are going to be the labeled indexes. So let's say names, and we're going to say Ellie, and we're going to say Mike. So Mike, like so. We're going to say Ted, and we're going to say Tom. Now remember, we have 4 different rows, so we need 4 labeled indices. If we don't have 4, we're actually going to throw an error when creating a data frame. So let's go ahead and, well, create those names. And then let's go ahead and actually create the months that these children worked at. So we're going to say, this is going to be a list as well. We're going to say April. And over here, we're going to say May. And lastly, we're going to say June. And the length of this has to be, well, the exact same number as the amount of columns that we have. Cannot be less, cannot be more. So let's go over here and we'll say months. And now let's go ahead and actually create our data frame. So df is going to be equal to pd.dataframe. And then what we're going to do is we're going to add the two-dimensional array. So we're going to say sales. And this time what we're going to do is we're going to provide the labeled index. And we're going to say that these are going to be the names. And then we're going to say the columns are going to be the months. So let's go ahead and create this. And now if you look at the data frame, you can see we get this really cool tabled structure. And again, a data frame is just multiple different series just combined with one another. So you can see here we have our labeled indices, and then we have our columns. Now let me just quickly show you what happens if, let's say, I remove Tom. So I'm going to remove Tom, and I'm going to try to create this data frame. And you can see here that we get an error. And that's because right over here, we only have 3 names, 3 labeled indices, whereas we have 4 rows. And that's just going to throw an error for us. So I hope you know exactly what I mean by this. And of course, the same thing is going to happen with months. So let me go ahead and fix this. But this time, let me go ahead and actually add a month. Let's say July. And let's go ahead and try to create this data frame. Well, now we have an extra column that we don't know what to do with because we only have really 4 columns. So it's going to throw an error. So now if we fix this, you can see it works okay. And we can actually do quite a bit of stuff with data frames. So let's actually go ahead and continue on. So right now we have created this data frame, but I want to create a more complicated data frame with a bunch of rows and a bunch of columns. Now, of course, we can create this by creating NumPy arrays and doing this over here. But another thing that we can actually do is load in and create a data frame by using certain files. Now, specifically, we're going to be using a CSV file, which are just a bunch of data that are separated by commas. So we're going to be using this one, and I'm going to link this inside of my GitHub. So what you can actually very simply do is either, well, clone my GitHub or copy this into your own CSV file and move it into the same directory where you're running your Jupyter notebook. And what you can do is you can do kind of an ls here to see your directories. And I'm going to move into pandas. And I am going to cd into, or sorry, I'm going to ls the pandas directory. And you can see that now I'm in the pandas directory. So let's cd pandas/data. And you can see inside of pandas/data, I have my cars.csv. Now, of course, you can put this in the root directory just to make it a little bit cleaner. But what is this? Well, this is just a bunch of data that is going to pertain to different car sales for a car dealership throughout the month. And it has a bunch of different information. So right over here at the very top, we have all of the different columns that are separated by commas. So we have the car type, we have the type of the car, we have the year of the car, the price of the car, was it financed or was it not financed? Then we have the day that it was sold. Then we have the dealer's name, the customer's name, the customer's social security, and then the customer's sex. So this right here are the columns. And then right below, we have all of the different rows. And again, they are separated by commas. And then each particular location is associated with the column that it's in. So this right over here, Mercedes-Benz, that is going to be right over here, which is going to be the car column. So let's actually go ahead and load this in and we'll create a data frame from it. So this is what we're going to do in order to create a data frame from a, well, CSV file. So we're going to say data frame, and we're going to say PD, and then I'm going to say read CSV. So we're going to read a CSV file, and then we need to define the path to where the CSV file is. Now for me, it's going to be in ./pandas/data, then cars.csv. But if you put it in the root directory, so just right in the directory where you're running your pandas Jupyter notebook, it would just be this like so. But again, for me, it's going to be this because I'm, well, running it in a different directory. Or I have this in a different directory. So let's go ahead and actually now look at it. And there we go. Now you can see I have a data frame that has all of the different columns and then as well as all of the different rows. And you can see that we actually have a bunch of different rows here. And we actually get the output of each particular row. And sometimes that can actually be a little bit overwhelming. And we might just want to have just a general view of our data frame. So what we can do here in that case is just do a df.head. And what that does is it just gives us the first 5 rows so we can have a nice general view of our data frame. All right, so now that we got that out of the way, let's talk about the topic of selections. In this video, we're going to learn a little something about conditional selection. So at some point, we might want to query our data frames a specific way. So for example, instead of getting every single record, I might want to get all of the different sedans, or I might want to get all of the different cars that have been financed. And I can, of course, go on and on and on, but you guys get the point. I don't want to get everything. I want to conditionally query my data frame. And that is exactly what we are going to learn today. So let's first actually discuss what happens if I do data frame and then I pick a particular column. So I say colon and then year like so. Well, what I actually end up getting is a pandas series. So you can see here we have this pandas series where this is a numerically indexed, and then of course we have our values here. And just to prove to you that this is indeed a Pandas series, what we can actually do is check the type of this. So we can say type, and I can say, well, I can say df of year, and there you go. I get a series. I get indeed a Pandas series. So what I can actually do now is utilize this series to make conditional selections. So for example, what I can do here is, let's say I want all of the cars that are older, or actually are newer than 2015. So what I can do here is I can say df and then year, and I can say greater than 2015. And what that actually returns to us is another Pandas series, but this time it is a Boolean series. So instead of having the values here, you can see here that we have, well, Boolean values. So instead of the years, now they are just Booleans, and they're either true or false depending on this condition. So in this case, these first two are true because, well, the year is greater than 2015. However, this one over here is false because, well, this one is 2015, and we didn't say greater than or equal to. So now we can actually use this Boolean series in order to, well, query and conditionally select certain rows within our data frame. So let's actually go ahead and actually grab this condition, and let's just assign it to a variable. So we'll say something like Boolean series, and we'll say this. And then what we can do here is we can say data frame, and then we can supply it with this Boolean series. And what it's going to do is, if the value of this series is false, it is going to completely omit that row. However, if it's true, then it's going to show that row. And now you can see we get all of the cars that are newer than 2015. We have no cars that are older. So what we had to do here, though, is we had to actually assign this to a separate variable, and then we passed it into the data frame. Now, we actually do not really have to do this. This was just for kind of an illustration purpose. What we can do, and what is typically done, is we have the data frame, and then we have a condition right inside of this square brace. And there we go. We get the exact same result. So I hope that makes sense. All right, so that is how we can do conditions. And of course, we can do many different conditions. We can say maybe we want the data frame, let's say the data frame where, so we're going to say data frame, and then over here, finance is equal to yes, something like that. And now if I were to select for that, of course it would fail. That's because I should do this outside is equal to yes. And there we go. Now we get all of the cars that have finance equal to yes. And again, we can go on and on and on and on. I hope you guys get the point. However, there are some times where we're going to want to have multiple different conditions. So for example, maybe I want to, well, query for all of the different cars that are newer than 2020 and have a price that is greater than or equal to 100,000. Well, let's talk about how we can do that. So right over here, we have two different conditions. So the first condition is the year is, well, greater than or equal to 2020. And then the other condition is the other condition is that the price is greater than or equal to 100,000. So we actually have two of these conditions that we want to apply when selecting certain rows from our data frame. So we can actually combine these two conditions together by actually having a parentheses between them. So we can have a parentheses between each condition, and then we can very simply just say right over here the ampersand sign. So we can have this condition and this condition needs to apply. So now what we can very simply do is just add this condition to our data frame. So we can just wrap it up in a square bracket and just say df like so, and there we go. Now we have, well, all of these conditions are passing. So you can see here, every single year is 2020 or greater. So we have the really expensive cars. We have like the BMWs, the Maseratis, the Porsches, the Bentleys. And then we also have, of course, the prices are very expensive. So we have 160,000. Everything is above 100 grand. So I hope this is clear. So this is how we utilize this if we want both conditions to apply when we are selecting the rows. But sometimes we're going to want maybe one condition to apply. So we can say something like, hey, I want it to be, let's say, greater than 2020, or the price is greater than 100,000. Now, in order to do that, we're going to use a pipe. So over here, we can do the exact same condition, but this time, instead of saying and, we can say or. And if I were to apply this, now you can see we have a bunch more, and we have a bunch more different cars. So let's say now we have the Toyota, which is a 2022. However, the price of the car is not 100,000. And that's because it met this condition, but it did not meet this condition, which is completely fine because now we're saying, hey, I want this condition to be met, or I want this condition to be met. Whereas over here, I'm saying I want this condition to be met, and I want this condition to be met. So I hope that is clear and it makes sense. So let's actually go ahead and do one more for practice. Let's say I want to get all of the different cars that we sold on the weekend. So what would we have to do for this? And I highly suggest pause the video and kind of try this out on your own. So I'm going to do df. And the first condition is going to be df. And then I'm going to say, what was the column name again? The column name was day. I'm going to say the day is equal to Saturday. Now, obviously, there's another day that's on the weekend, and that is going to be Sunday. So let's go over here. We're going to say df. And apologies if you have weekends and different days in different countries, but this is how it is in North America. So we're going to say now Sunday. So this is going to give us all of the different cars that were sold on Saturday and Sunday, which is, of course, the weekend. So now if I were to run this, of course, I'm getting absolutely nothing here. Let's see why that is. We got df day is equal to Sunday. Oh, of course, this should not be an and. This is actually a good example. So over here, we're saying that the day is equal to Saturday and the day is equal to Sunday. It should be an or. And there we go. So you can see we get all of the car sales that were sold on the weekend. But now let's say that, well, I want you to give me all the car sales that were made on the weekday. Now you might be thinking that the only way of doing this, and this is kind of a tedious way of doing this, is doing something like this: Monday, and then Tuesday. I believe that's what I called it. Did I add an S in that Tuesday or no? Let's find a Tuesday here. I can't really find a Tuesday. Whatever, let's just leave it as is. So Tuesday, and then you might be thinking, oh, I'm going to have to add one for Wednesday, and on and on and on. And of course, this is 100% a valid approach. You can do this. But when we have so many different or selections, what we can actually do is a neat little trick. So instead, what we can say here is define all of the values inside of a list. So I'm going to say here Monday, and I'm going to say, and of course, this has to be an exact match, so the capitalization really matters. So we're going to say Monday, Tuesday, Wednesday, Thursday, and lastly, we're going to say Friday, like so. And then what we're going to do here is we're going to say df of day, and then we're going to say dot is in, and we're going to wrap our array in these parentheses, and we're going to just treat it like a parameter. So what this is going to do is, in essence, what we just did what we just did before, but it is significantly significantly simpler. So now we can just wrap this in a df, because of course this is going to return to us a Boolean array. So we can just wrap this in our regular data frame. And now, you can see we have no weekends, only weekdays. Looking great, looking terrific. All right, so that's pretty much all it is that you really have to know with conditional selection. In the next video, let's talk about some more Pandas stuff, and especially some stuff related to DataFrame methods. So let's talk about that. In this section of the course, what we're going to do is explore some of the many built-in Panda methods. So for example, if I went over here and I went data frame of price, and then I did dot, and then I did a tab, and I just waited a tad bit, you can see that there's actually a bunch of different methods that I can utilize in order to, well, do either data analysis or manipulation on that particular column. Now, we're not going to go through every single one because there's, well, just quite a lot. And of course, if you have a specific purpose, you can always go ahead and search it up on Stack Overflow and find the method that works for you. But for now, what we're going to do is we're going to work for the more common ones. And if you understand them, I think you'll understand the rest. Now, the first one that I want to talk about is the apply method. So let's go over here. Let's add some markdown. So let's go here, markdown. And let's just make a big title, and we're going to say apply or dot apply like so. So what is this dot apply method? Well, this dot apply method allows us to run a Python function within our data frame. So for example, let's say that I want to add a new column in this data frame, which is the price after tax. So this right here is the price that the car is, but this isn't the price that the customer paid. They, of course, have to pay the price itself plus the tax. So let's say I want to create that column. Now, in my country, which is Canada, in Ontario, the price is, or the tax is 1.13, so 13% on top of course, the price itself. So let's go ahead and actually create a function for this, and I'm going to call this price after tax, and this is going to take in, well, a price because it needs to know the price first, and then what it's going to very simply do is return the price times, at least for me, it's 1.13, which is going to be 13%. Now, if it's different for you, you can either change it or you can just use 1.13. It doesn't really matter. Now, I'm going to want to round this because I don't want to have like a million decimal places. So I'm going to use the built-in round Python method. I'm going to say I want to round to the nearest 0 digits. All right, so now I have this wonderful function that I can actually utilize within my app. So if I went ahead and I did something like, let's say, price underscore after tax, and I actually passed in this right over here. So let's just say, let's say I'm going to pass in, I'll just pass in whatever the first one is, which I believe, well, I'll just say this one with the index of 2. So what I can do here is I can say, well, I want to pass in the Nissan Altima. So I can say, well, I want to pass in the price and the second index. And that's going to give me, well, the price that the actual customer paid, which was 17,000 times, or 17,500 times 1.13. All right, so this is looking good. But what if I want to actually add this to every single column? I want to run this function for every single price that I have in my application. Well, that is where the apply comes into place. So what we can actually do here, very simply, is create a new column. And we can create a new column by doing df, and we can call this column whatever it is that we want. I'll just call it the same as the function name. It doesn't have to be, but I'm just going to say it because that makes sense. Or maybe I can say total price just to make it make a little bit more sense. So I can say something like total price, and I can say total price is going to be equal to, and then df of price. So over here, we're creating a new Python series and adding it to the data frame. And how are we constructing this series? Well, what we're doing is we're getting every single record within the price series. And then what we're doing is we're going to apply this function right over here that we just created. So again, what this is going to do is it's going to get every single price and then call this function on it, and then whatever the return value is going to be for that, it is going to append it to this series that is going to be connected to our data frame. So now if I do df and I scroll, you can see now we get the total price that the customer paid, which again is going to be the price times 1.13. All right, so cool. So that right there is the apply method. Now, there is one little limitation with the apply method, and the biggest limitation actually is that we can only really utilize one column. But what if we need to utilize multiple columns? For example, what if we want to have a column that is going to tell us whether our margin of profit was high or low? And that really depends on the price that the car was sold at, as well as whether the car was financed or not. So if the car was financed, well, there's a higher profit margin even if it was a little bit cheaper than if the car wasn't financed. So let's go ahead and actually write a function for this, and maybe it can make a little bit more sense. So let's go over here, and we're going to say profit margin. And we're going to say this is going to take in two different parameters, the price as well as the finance. And we're going to say if the finance, so if finance is equal to, and we're going to say, we got to actually spell it right, finance. So if finance is equal to no, then we're going to say if price is less than 10,000, then we're going to return we just made a low profit. We didn't really make a high profit. Then we're going to have an else if, or we're going to say if the price is greater than or equal to 10,000. So greater than or equal to 10,000, and the price is less than 25,000. Then this is going to make us, let's say, we're going to return medium. So this was a medium profit margin sale. And then else, if it's none of those conditions, then it's going to be a high. However, if the car was indeed financed, then these numbers are actually lower. So it takes a less sale to even get maybe a higher or medium profit margin status. So let's go over here, and I'm going to say else, and I'm going to go ahead and actually just copy what we have here. So over here, it is indeed financed. And what I'm going to do is I'm going to say 7,500. Over here, I'm going to say 7,500. And over here, I'm going to say 20,000. So if this doesn't really make much sense to you, it's okay. All I'm trying to say is that if you finance your car, then we're going to make a higher profit margin than if you don't finance your car, basically at the same price. That's what I'm trying to get at. But nonetheless, what you really need to understand is that this function over here takes in two different parameters. And how are we going to utilize that with .apply? Well, we're actually not going to utilize with that .apply, because with .apply, we can only utilize one column. So instead, we're going to utilize something called vectorize. And this is actually not going to come from pandas, but rather from NumPy. So I'm going to say here, profit margin, and I'm going to say that this is going to be equal to np.vectorize, and then we're going to pass in the function that we just created, and that is going to be the profit margin. So what this does is it vectorizes our function. So this function currently is written in Python, and it has no idea what NumPy even is, what pandas even is, or anything like that. Now, when we do NumPy or np.vectorize, we are vectorizing this function so that now it's aware that it is, well, NumPy. It is NumPy aware. And that is going to make it faster, and that is also going to allow us to pass in multiple different columns. So this right here is a function. So what we can do here is we can actually call this function, and we can pass in df price. We can also pass in df finance, like so. And now if I do an enter and I do a df like so, we should indeed get this column at the very end: high, medium, low, low, etc. So I hope that makes sense. So that was probably one of the more confusing confusing functions. Now let's go look at some of the more handy and less confusing functions. So one thing we can also do on our data frame is describe. And this is just going to give us a bunch of different information about our data frame. So you can see here the year, the average year of our cars are 2016. You can see the min year, the smallest was 2000. You can see here 25%, 50%, 75%. You can see the count, we have 45, etc., etc. And this only actually does these calculations on columns that have all numbers. So of course, if it's going to be a string, it is not going to be able to do that calculation on that string because you just can't do this kind of information. Now over here, we also do have it with the price, the social security. Even though this is a number, this is kind of useless information. And of course, the total price, I think that is pretty well useful. Now, in my opinion, I actually think it would look a little bit better if the year, price, social security, and the total price were on the x-axis, while these over here were on the y-axis. So what we can actually do is to kind of flip that is do a df.describe, and then we can invoke the describe like so, and then we can do .transpose. And that's just going to flip the order around. So this looks a lot better and a lot cleaner to me. All right, so now let's look at some other ones. We're just going to kind of quickly breeze through this. So another really cool one is sort. So we can actually sort our data frame. So maybe we want to sort our data frame by the price. So we would say sort values and then price. And as you can see here, we get the price that has the lowest value first, and then it goes all the way to the price that has the highest value, which is the Bentley, of course. Now we can of course sort by multiple different things. So let's say that we have right here. So we have two cars that have the same exact price. Maybe then at that point, what we want to do is we want to sort by their, let's see here. Yeah, we want to sort by their year. So for example, we want maybe the older car to be first. And in this case, it is first. Maybe we can find another example here. There we go. No, that's exactly the same. Let's see here. I don't think we can find another example. Okay, here's a good example. Okay, let's say, yeah, so we got the same thing. Then we want to sort by the year. In this case, it is. But what we can do here, I guess we can't really find a good example, but let me just show you what I mean. So we can say df.sort values, and then I'm going to pass in an array this time. And first it's going to be by the price. And if the price is the same, then it's going to sort by the, let's say, the year or the sex, even if we wanted to. Now over here, we can go ahead and invoke that. And you can see now, again, if it's the same, let's try to find one that's the same. For example, this right here is the same. Well, now it's sorted by the year. And I know before it was basically the exact same thing, but now the sort was actually explicit. All right, so that's pretty much all it is for sorting. I don't think there's anything else that we need to talk about. Let's talk about some other quick and easy methods. Let's say we want to very quickly find the max price of a particular series. We can say, df of price. We can say .max. That's going to give us the max price. And then obviously, if we want the min price, we can just do .min, and that of course is going to give us the min price. Maybe we want to know the index of the max price as well as the min price within our data frame. So we can just say over here, df of price, and then we can say for this, I want the index of the max price. That's going to give me 44. Now, let's say the index is not really useful information for me. I actually want to have the record itself. What I can do here is I can say df.iLocal, so index location is what it stands for. And then I can say that particular index, then it gives me information about the car, the type, the year, etc. So of course, I'm not going to have 44 memorized. So what I would do instead is df.iloc, and then over here I would do this inside of these braces, which is going to return to me 44, and again return to me the car that I want. All right, so now let's say I want to figure out the well, how many records I have. So I can say, for example, df of sex, and then I can say value count, and that should return to me how many records I have. Well, actually it didn't, because it's value count, not value count. And that's going to tell us that, hey, I have 26 males and I have 19 females. So as you can see here, now I can actually do the exact same thing with the cars, and this also might be kind of useful information to know which car is kind of popular to sell. So it seems like the Hyundai is the most popular selling car, whereas the Bentley is, obviously it's a very expensive car. Not a lot of people can afford it, so it's at the 1 stage. All right, so that is looking good. Another thing that I actually want to talk about is the dot replace. So right over here, you can see that, so you can see over here, let's just say with the male and the female, let's say instead of utilizing M and F, we want to just explicitly say male or female, because I don't know, maybe you have a bunch of employees that don't really understand exactly what this M and F means. So what we can do here is actually use the dot replace. So we can say here df of sex, and we want to change this. So we're going to say df of sex is going to be equal to, and then I'm going to say df of sex, and then I'm going to say dot replace. And then I'm going to first specify the value that I want to replace. So I'm going to say to replace, and I'm going to say M. And then over here, I'm going to say what I want to replace the value to, and I'm going to say male. And now if I did df, if you look at the sex column, you can see we have male F, male F, male F. Now, of course, we could do the exact same thing. Let me go ahead and just copy this. Copy that and paste that in here. You can change that to F, change that to female, and of course that is going to now convert it from M and F to male and female. That is looking really good. Let's just go through some more methods. So I'm going to go ahead and do a df, and this time I'm not going to do it on any particular column. I'm just going to do a df dot duplicate, and what this does is it tells us if there's any duplicate records. So if there's any rows that have exactly the same value for every single column. So you can see here it says false, 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 false. So it essentially returns a Boolean series, and you can see here we have some true values. Now, of course, let's say we want to actually see what those values are. So we can say here df, and then we can say df dot duplicated, and then go ahead and invoke it. And you can see here the Jeep Wrangler as well as the Hyundai accent. So if I were to go here, you can see the Jeep Wrangler. So we got one Jeep Wrangler here. And let's see if we got the exact same record for the other Jeep Wrangler, or Wrangler, or whatever it's called. That doesn't look like the same record. Maybe there's another one out there. There we go. So what it's going to do is it's going to iterate through every single row, and let me actually just go ahead and just filter for, just so I can really illustrate this a little bit better. So I'm going to say df, and I'm going to say df of car. I'm going to say it's going to be equal to this. So what it's going to do is it's going to iterate over this one first. And well, of course, the first iteration is not going to have any duplicates. So then it's going to move on to the next one. So for this one, it's going to return false. Then it's going to move on to the next one. Well, this one has the same car type, but it has a different year as well as a different price. So this one's going to return false. And then it's going to move on to this one. Well, this one is exactly the same as this one over here. So this one, it is going to return true. So this right over here is going to return true. Now this one already returned false. This one's going to return true. And if there's any other instances that match these ones over here, it's also going to return true. Now this one doesn't. Different customer, different price, etc., etc. So I hope that is kind of clear. Now let's say that we want to get a list of all of our cars, but we just want to get a list of all of our unique cars. We don't want to have duplicate cars. We just want to know what cars did we sell. What we can do very simply is just say df of cars, and then we can say dot unique. And over here, it's just going to give us a unique list of all of our different cars. So even though over here we sold the Jeep Wrangler 3 times, it just kind of compressed it to one string. So we can have a list of all the different cars that we sold. And maybe the cars that we haven't sold, we can just kind of get rid of it. We can also maybe figure out how many cars that how many unique cars do we have by doing df cars and then n unique, and that's going to say, hey, we've sold maybe 19 different types of cars. All right, so the absolute last method I promise this time that I want to talk about is between. This one's really, really easy. Maybe we want to find the cars that have a price between 10,000 and 20,000. Of course, we can do that with just kind of a regular selective condition, but we can also do that with the between method. So I can say here between, and I can say between 10,000 and 20,000. And you can see here that that is going to give me a Boolean series. And of course, if I do a df of that series, you can see here I get all of those cars. All right, so I think that pretty much wraps it up for the useful methods. Again, there's a bunch more, but hopefully I gave you a good introduction of how to use some of these and some of the more common ones. And if you ever need a particular use case, you can just go ahead. And in this section of the course, we're going to learn about group by. And to better understand group by, let's take a closer look at our data frame. So over here, we have our data frame that has multiple different columns. Now let's say that we are trying to better understand our data frame and better understand the data within it. So what we want to do is we want to group by a particular category and analyze the aggregate data. So what do I mean by that? Well, let's just take a look at an example. Let's say I am very interested in knowing how much each of my dealers have sold throughout this time period. So I just want to get the total sum of all the cars that they have sold. So basically the price of all of these cars. So what would I have to do? Well, I would have to aggregate all of these or group these dealers by their name. So over here, instead of having something like Mike, Mike, Tom, Tom, what we would do is we would group them together so that we have one Mike and then one Tom, and then we would do some sort of aggregate function. In this case, it is going to be the sum in order to find the sum of all the prices of the cars that they have sold. And this is just going to give us some more information about, well, how much, well, money they earned us, and we can do more and better data analysis. All right, enough of that. Let's actually just take a look at how we can do that in Pandas. So let's go over here in a brand new cell. And what we're going to do is we're going to do df, so the data frame, and then we're going to say group by, and then we're going to specify the category that we want to group by, which is going to be the column. Now I'm going to say dealer, and then after we group by, what we need to do is we'll have some sort of aggregate function. So do we want the sum? Do we want the mean? Do we want the min, the max, etc.? So now what I can do, let's say I want the sum. So now what I can do is do shift enter, and you can see here that it groups by dealers, and actually the dealers become the labeled indices. And then right over here, we have our columns. Now notice here that we actually don't have all of the columns in our data frame. It actually only includes the numeric ones, which it can perform a sum on, because obviously it can't perform the sum on days. Like, how is it going to understand what Monday plus Thursday is, or customer or Todd plus Taylor? It's not going to really understand that. So what it does is it completely removes all of those other columns, and it just works on the numeric one. Now, for examples like this, the year is not really that useful, having the sum of all the years, and same with the social security, not that useful. So what we can actually do here is, maybe if you want a particular category, we can just say .sum and then select, let's say, the price, and then you can see here we get the price of what we want. So I hope that makes sense. So just as a quick reminder, when we do the group by, the actual category becomes the labeled index, and then right over here, these become the columns. And we can actually prove that by very simply doing a df. So let's just do a df.groupby, and then dealer.sum, and then we can say .index. So you can see the indices are going to be the names of the dealers, and then we can actually do .columns to see all of the different columns. So .columns, you can see we get year, price, social security, and the price after tax. Now notice here that this dealer is not a column. This is just going to represent the name of these labeled indices, and that's why it's on this line over here, whereas this one is on the upper line. All right, so I hope that is nice and clear. Now, one really cool thing that we can actually do is, of course, we can have different types of aggregate functions. So let's just go ahead and just explore some of them. So I'm going to say, let's say df, and then let's say we want the mean this time. So you can see here, on average, Brittany sold cars that are 2012, Mike sold cars that are 2018, and you can see the price. So now we have a little bit more useful information. Obviously, the social security, I don't really care about the mean for that, but you can see that we have a lot of useful information like so. You guys probably get the point. There's just a bunch of different aggregation methods that we can utilize, and you can probably search them up on some Pandas documentation. Now, the next thing that I want to talk about is we can actually group by multiple different categories. So for example, we could, if we wanted to, do a df.groupby, and over here, instead of passing in the category string, we pass in an array. So we're going to say dealer, and then comma, and then we're going to say year. And then we're going to, of course, still supply it with that aggregation method. And what this actually creates is a multi-index array. So you know how before we had the dealer be the index, which is, of course, this is our labeled index. Now we have two different indices. So the first row right over here, the index of this is going to be Brittany and 2000. Then the next row is going to be Brittany, 2020 or 2002, and then so on and so on. And now we can actually get even more precise information about maybe, you know, how much 2020 cars did Brittany sell. And you can see here it sold, 78,000 worth of cars. So now you can see we get all these different informations. Now, to just show you exactly what a multi-indexed table is, or a data frame is, these two right over here, they're not columns. Again, they are indices. These over here are the columns. So let's actually do exactly what we just did before when we, well, fetched the indices as well as the columns, but with this data frame. So let's go over here, and I'm going to do .index, and you can see that the indices are actually tuples. So you can see here this first tuple has the string of Brittany and then 2000. And then over here, the string of Brittany and then 2002, etc., etc. Now the columns are actually going to be exactly the same. So if I went ahead and grabbed this and we said columns, you can see the columns are exactly the same, but now that we're grouping by two different things, we have a multi-index data frame. So you might be thinking, well, how in the world can we actually go ahead and start fetching data from a multi-index data frame? So what I'm actually going to do is I'm going to grab this data frame, and I'm going to call this dealer year, because it has just a relationship between dealers and the year of the car. And I'm just going to go ahead and assign it to a variable. Now, of course, if I did dealer year, we get our multi-index data frame. So we get the same exact thing. So one thing that we can actually do is instead we want to maybe fine tune on a particular dealer. So maybe we don't care about every single dealer. Maybe we just care about Mike, who is our top performer. So what we can do to just get the data associated to Mike, what we can do now is we can grab this dealer year and then do .loc, and then we can specify that labeled index, which is Mike. And over here, you can see that we actually just get a regular data frame where the year now is the index. So it's not a multi-line index anymore. We just have the year be the index, and then we have the columns over here. And now we have all the information that we need for Mike. Now, let's say we want maybe all of the information for Mike and Brittany. So, of course, we can do the exact same thing, but instead of passing in a string here, we can pass in an array of strings that are going to be, the labeled indices. So now you can see here we get that multi-line or multi-index data frame. So that's because now we are utilizing two different indices. So now we get that again. But of course, now we can distinguish between this data frame, because this one only has Mike and Brittany, over, well, the one that have everything else. All right, so now let's talk about the last type of filtration. Maybe what we want to do is we want to just get the data for the dealer of Mike and the year of 2019. We just want to get that information. Well, we can actually do that again very, very easily. So this time we're just going to do that with dealers underscore year.loc. But this time, instead of passing in a string or an array, we're just going to pass in a tuple. So we're going to say Mike, and then as the second parameter, that's going to be the year, which is going to be 2019. And if I were to do that, we get an error, and that is because, of course, this has to be in not parentheses, but square brackets, like so. So there you go. Now we get this series that actually has all this information. So this is how we can actually do some fetching with these multi-index data frames. So I hope you guys learned a lot with this. It was just kind of the basic introduction of pandas as well as data frames. I hope you guys learned a bunch, and now you guys are relatively comfortable with pandas. I'll see you in the next video.